So more from the January 2017 exam. We gave this problem number 13, and it was surprising how many students missed it. Very easy to do, though. I could see what happened. There's a cross between using the side splitter theorem and making sure that we have corresponding sides on similar triangles are proportional. So here's the mistake. Some of our students treated 15 to 9 as they were working on this problem, which is the side splitter theorem. That's not what this is. Okay. What we had to do, or what was intended, was for you to add the 9 and the 15 to get 24. Okay. The 9's really the extra piece, which I can show you how to use in a minute. But really what was intended was these are your corresponding sides, not these. Okay. And then 40 and what I'm going to call x should be corresponding. So I should use 15 is to 24 as x is to 40 as my proportion. So when we cross multiply, 24 times x equals 15 times 40. 600 divided by 24, and we should get 25. Okay, so D to E is 25. All right, so how some students did it and messed up, they used 15 is to 9 as x is to 24. You can see that's a big issue. Okay, we don't want to do that, but a lot of people did. So let's be really cautious of that, and let's not go for that. All right, number 14. Interesting problem here. Okay, and what these choices are doing is they're not asking you for the exact image. So if you went and tried to figure out what the exact line was and graph it and do all that stuff, you actually did more effort than you needed to. Really all you had to do was focus on, okay, what's happening here? Okay, it is intended to test this theorem. Did you know that when we dilate a line, we get one of two things, either a parallel line or two, same line. Now, what we also have to know is we're kind of using dilations preserve slope. And in preserving slope, right, equal slopes. So equal slopes give us parallel. So there's a lot of concepts that are tied together in this course if you know how to do that, and it makes the course a lot less challenging because you don't have to remember quite as much. Now, if we read the choices, the image of a line has the same slope, okay, as the pre-image, but different y-intercept. That's possible. If we look at that one, that sounds okay. When we will have a different y-intercept is what I'll talk about. It's because you'd have a parallel line, not the same line. All right, same y-intercept, but a different slope. We know that's false because dilations preserve slope. Image of a line has the same slope, maybe, and same y-intercept. Okay, that would be the same line. So our two choices, 1 and 3, still have a shot here. Different slope, no way. So 2 and 4 are out right away, just because it's just not okay. Now, when we dilate a line, let's take a look at that equation, and it's centered at the origin. Here's the key. What decides between these two is if the center is off the line, then parallel line is the image. All right, if the center is on the line, then same line. All that happens is the points move further from the center or closer, depending on the scale factor. In this case, they'd move further from the center, the individual points, but they'd stay on the same line. Okay. Now, which one is it? Is the origin on this line? You could graph it and find out, but I won't. I'm just going to plug it in. 0, 0 is the origin. That means plug in x is 0, y is 0, and see if the equation works. So 3x minus 5y. So does 3 times 0 minus 5 times 0, does it equal 4? The answer is no. What's that mean? The center is not on the line, so we get a parallel line. Different y-intercept is how you get a parallel line. I'm going to go for 1. Okay? Not the same y-intercept. Which transformation would not carry a square onto itself? A line reflection over its diagonals does. Okay? So think of a square of, that does. A 90-degree rotation, that's going to, now, here's what a lot of students we've talked about before. If we go with a 90-degree rotation clockwise, that's this way, A would land on this point. So the point doesn't get back to its original location. It just gets to another location that is also on the figure. So now B would move to B prime. So basically every point has a match. 180-degree rotation about one of its vertices will not work. Here's why. To carry on to itself, say we do this. Say we pick point B, right? 180-degree rotation would take this over there. So this is A, this would be A prime. If this is C, this would be C prime, and so on. D, that would be D prime. So what happens is, basically I look at it like this. This image creates a new outline. In other words, every point from the pre-image does not have a match necessarily on itself. So there it is. Reflection over perpendicular bisector, yeah, that's going to do it. So 3 is going to not carry on to itself. All these other ones will. All right, number 16. In circle M, we label circles, we name them by their centers. So now you can see why we say it's circle M. Diameter AC, chords may or may not go through the center. In this case, neither one of these does. All right, here's a couple of ideas. When you have a situation such as this, you have a diameter. An inscribed angle that opens up to a diameter is a right angle. So that's one fact, okay? So which statement's not true? Triangle ABC is a right triangle. That is true. Okay, we're looking for which one's not true, so throw that one out. Triangle ABM is isosceles. That's actually true because A to M is a radius, and so is B to M. They have to be the same. That's true. Get rid of it. Arc BC, okay, this is challenging. Measure, it's the arc angle measure. The arc angle measure of B to C, whatever it is that the same as angle BMC? Let's make something up. Let's say it's 130. This arc angle measure and this central angle measure are in fact the same measure. This is actually true. So it must mean that this one's going to be false. Let's see why. The measure of arc AB, let's say we continue with this, is, let's use the 130 here. We'll just make an example. So that's 50, right? Because together they have to make 180. The arc angle measure has to be 180. So then we got 50. Now what's the measure of angle ACB? Okay, it's half, so 25 degrees. Now, did they describe it properly? If you take the measure of the arc, is it half the measure of the angle? No, because that's 50 and half of 25 is not. That's not the same. They got the half of the wrong thing. Okay? So that's why this one's false, which is the one we're looking for. Tough one. Very tough one. All right, number 17. These figures might not be congruent. XY perpendicular. Okay, so both. Okay. So we got right angles there and we got vertical angles here. We know they're at least similar figures. At least. And we don't know for sure if these bisect each other. So let's just be careful and just assume they're similar. Which statement must always be true? Is XS definitely the same as YR? I don't think so. That does not have to happen. In fact, it can't happen. Yeah, it cannot happen. These are the hypotenuses of right triangles. They have to be bigger than the legs. So this cannot happen. All right. Is triangle XYZ congruent to SRZ? It looks like it. That's a maybe, but we can't really prove it yet. I wonder what these are about. Okay, so let's we got to write a similarity statement and then see which ones of these is good. So it's really XYZ is similar, XYZ to SRZ. This is the best way to go about doing this. Now we can easily test this. Is XY proportional to SR? That checks. Is YZ proportional to RZ? That checks. That is true. This is going to work. Let's eliminate this one though. Y. Okay, if I was converting this, this is the result of a cross multiply problem. It would go like this. And then XZ and RZ. Let's check this out based on our similarity statement. Okay, does XY correspond with RZ? Right there is the issue. See that? That's the first and second letters. That's the second and third. So that doesn't work. This is a false. This is better. Even though we didn't say that this won't work, this one does for sure work. So we're still up in the air. This is a true. Let's use it. All right. That's it for this video, and let's get to the part 2s on the next one.